So y is equal to g of x. G of x is a cubic. We're trying to work out what this cubic equation is. Let's just represent all of the coefficients as letters. So ax cubed plus bx squared plus cx plus d. So for the first bullet point, we're told that the coefficient of x cubed is equal to the coefficient of x. So what that means is a is equal to c. Coefficients are the numbers in front of the x terms. So the coefficient of x cubed is just a, and the coefficient of x is c. For the second bullet point, the curve with equation y is equal to g of x passes through the origin. So that means that the point 0, 0 is on our curve. So what that means is that g of 0 would be equal to 0. We put in x is equal to 0, and that should give us 0. For the final bullet point, the curve with equation y is equal to g of x has a stationary point at 2, 9. So there's actually two things that we can get from this last bullet point. One is that the curve must pass through this point of 2, 9. So that means that g of 2, put in 2 into our function, replace x with 2, and we should get 9 coming out. And secondly, when we differentiate our function and put in x coordinate of 2, because it is a stationary point, that means the gradient is 0, so this should equal to 0. And again, we're trying to find what g of x is equal to. Okay, so I'll start applying these points or bits of information to our function. So I'll start with the first bullet point, a is equal to c. That means we can write g of x as ax cubed plus bx squared plus ax. So I've replaced the c with a, and then plus d at the end. For the second bullet point, so that corresponded to this bit of information here, g of 0 is equal to 0. So let's apply that now. G of 0 will be 0 plus 0 plus 0, so setting all of the x terms to 0, plus d, and that's equal to 0 in the end. So that tells us that d is 0, so our equation is now ax cubed plus bx squared plus ax. And in the final point, so we have two bits of information. The first was that g of 2 is equal to 9. I'll start with that. So put in 2 for x. This becomes 8a plus 4b plus 2a is equal to 9. So that's using this equation here. Simplify this, we end up with 10a plus 4b is equal to 9. I'll call this equation 1. So we can't solve this equation, we have two unknowns. We're going to have to find some other kind of equation that either tells us a or b, or involves a and b. And then for the final part of that bullet point, so g of x has a stationary point at 2, 9. So then that was this bit of information here, g prime 2 is 0. So we need to differentiate our function to begin with. So then g dash x, differentiating what we have over here, will end up being 3ax squared plus 2bx plus a. We know that when we put in 2 into our differentiated function, we should get 0 coming out. So g dash of 2 is equal to 12a, so replacing x with 2, 12a plus 4b plus a. And because this is a stationary point, when you put in 2, this should give you 0. So again, that's just applying this rule here. Okay, so simplify this, we end up with 13a plus 4b is equal to 0, and here is our second equation. Now we can solve equation 2 and 1 simultaneously, so I'll write them next to each other. 10a plus 4b is equal to 9. 13a plus 4b is 0. I can take the two things away. 9, 0, minus 3a. So 3a or minus 3a is 9, and a is therefore minus 3. I can put that back into one of these equations. So I'll put that back into equation 2. So for equation 2 I end up with minus 39, that's 13 times a, 13 times minus 3, plus 4b is 0, and then rearranging this for b, we'd end up with 39 over 4. Now our goal was to work out what g of x was. Find g of x. G of x was this. We've now worked out what a and b are, so we can put those two things in, and we end up with g of x is equal to, so it was ax cubed plus bx squared plus ax, so that will be minus 3x cubed plus bx squared, 39 over 4, plus ax, so that will be minus 3x. So that's our answer to part A. Now for part B, prove that the stationary point at 2, 9 is a maximum. So to find the nature of stationary points, we have to double differentiate. So let's differentiate this once, first of all. G dash x will give us minus 9x squared. So 2 times 39 over 4 will be 39 over 2, minus 3. Differentiate one more time, g double dash x. That will be minus 18x plus 39 over 2. And then what we do is, so we know that g prime of 2 is 0. So in other words, 2 is a stationary point. We're trying to find out the nature of this stationary point. So does it look like this? 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 We're trying to work that out. So we first put in that 2 into this function here. So g double prime 2 is equal to minus 36 plus 39 over 2, which is minus 33 over 2. This is negative. So the double differential, it tells you the rate of change of the gradient. So g double dash of x is the rate of change of the gradient. So if it is positive, that means the gradient is increasing. If it is negative, that means the gradient is decreasing. Our double differential is negative, so what that means is our gradient is decreasing, and therefore it must be a local maximum. If we look at what we have here, if I were to draw successive tangents, here the tangent is positive, here it is less positive, 0, negative, more negative. So as we go towards the right, the gradient is decreasing, which is what we have here. G double prime tells us the rate of change of the gradient. That is negative. Our gradient is decreasing, and therefore we must have a local maximum. So that will be our final answer. So from this bit of information here, we can therefore say we have a local maximum.